Back over here. All right, so hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We're just going to go over quick C++ principles as a review. So once you have created your project, you'll need the Solution Explorer. I'm going to pretend you don't have a Solution Explorer over here, so I'm going to close that. You can just simply go to View and then open the Solution Explorer over here. It looks like the keyboard shortcut is Control-Alt-L. I'll just click Solution Explorer, and then I'm going to pin that down so it doesn't go anywhere. You'll notice that there's the Source Files folder. I'm going to right-click on that Source Files folder, add a new item. And the new item that we're going to add is a C++ file. So over here, I have all kinds of different options. C++ is already selected. It's going to give a name of source.cpp. That's fine for what we're doing. I can just leave it like that. I'm going to click Add. And so you'll see over here that it gives you the C++ file so we can start typing in code. All right, well, the first thing I'm going to do is I'm going to type include iostream. Now, iostream is that library that is used for all kinds of tools that deal with input and output. A stream of water is either flowing downhill or it's flowing this direction or that direction, kind of like a walkie-talkie. Walkie-talkie should be used for couples. My wife and I, we argue, right? And so walkie-talkies are great for spouses because only one person can talk at a time. And so on a cell phone, which is full duplex, and walkie-talkies are half duplex, only one person can talk at a time. Whereas in a cell phone, that both people are talking at the same time. All right, so iostream basically is responsible for all of the input-output commands that you can use in C++. The next thing that we'll do is let's go ahead and include the string library. So anything that has to do with writing to strings, outputting strings, developing strings with spaces, characters, what have you, concatenating strings, getting a part of a string. Those are the tools in the string library. So what you can do is you could think of these as toolboxes. If a carpenter walks in through the door with a toolbox, I expect to see a hammer. I expect to see maybe some special carpentry tools like shaving tools or what have you. If a mechanic walks through the door with a toolbox, I expect to see pneumatic tools and wrenches and sockets and stuff like that. So these are toolboxes, and they have tools inside of them. Again, this is another toolbox, specifically dealing with strings. All right, and then we're going to say using namespace, and the only reason why we do this is because we're trying to include the standard library. STD has cout, cin, swap. It has all kinds of math functions like pow and square root, sqrt. So it's a collection of these tools that we use, and this is how we bring in the standard C++ library. Then we type in int, open close parentheses with the open close curly braces. This is a function. The name of this function is main, and this thing returns an integer. So typically what we'll do is down here over at the bottom, we'll say return 0. And if your program executes and reaches the return 0, what it's doing is it's communicating to the operating system. Everything went fine. Everything was kind of like open and shut door policy, no problems. Now, if there were a problem, like say, for example, maybe part of your memory is broken, maybe the display memory is broken, maybe if you had a hard drive that crashed, say, for example, then you know that Windows has these beeps. If you heard these, like sometimes it's one beep or two beeps, or maybe it's a series of beeps. Well, that means something. And in this case, we were not able to return 0 because perhaps something happened in our program or something's going on with the computer. This is the standard of what you do when you're typing in your main function. Every C++ program must have a main function. Okay, and then now here's the controversial part here. A lot of instructors don't like it when I do this. System pause. The reason why, and it's a valid reason, instructors will get mad at me when I do this because they'll say, well, your C++ program is no longer portable. And that's true because only Windows understands this. If I ran a C++ program on the Mac, on the Silicon Graphics workstation, on some other platform, it won't understand what system pause means. But since this class is primarily C++, I like to do this just so that I could stop the program and see what the output looks like. Okay, but if you're going to be creating portable programs, then yeah, you don't want to do this because you want your program to run on the Xbox, on the PlayStation, on maybe some other console or some other operating system. I only do this because I know we're using the Windows operating system. In general, you are going to create the following comments. So we'll say declarations, get user input, calculation, and then output. In general, this is the flow of your program. This is kind of like pseudocoding. What are you going to do first? What are you going to do second? So forth and so on. Pseudocode means false or fake code. It's basically like you organizing your ideas. Can you imagine I'm holding in front of me a bunch of these stickies, and let's say that I have commands on these stickies. And your job is to organize the commands, right? Because okay, we got a baseball game, so one of these stickies is going to say create the lineup. Another one is going to say put the bases on the ground. Another one is establish the pitching machine. Put the players, because we were talking about little players, put the players' baseball bags in order. Okay, so what should we do first? What should we do second, third, and fourth, right? So you've got all these ideas, these things that you need to do. Your job is to logically put them in order. And so pseudocoding is a great way to kind of put your thoughts down. And I always think to myself, if I'm doing something very simple, I don't put comments. But if I'm doing something that takes, I don't know, 15, 20, 30 lines of code, and it's kind of like an esoteric thing, like I'm taking words from a string and I'm reversing them. And maybe I want to describe how I go about doing that. Or maybe I'm writing a Pig Latin program where I have to, if it's a word that begins with the vowel, I add ay. But if it's a word that begins with the consonant, I take the consonant, move it to the end, and then add ay. So maybe I better describe what it is that I'm doing, the top level idea, because otherwise what ends up happening is you or another program has to decipher what you did. And we don't want too much of that happening. We'd rather just simply have an explanation. This is what I'm doing. So that's what these comments are all about. By the way, just a quick reminder, there is such a thing as a like a global comment or a block comment, and that's with the / asterisk. So this is a block comment. And so what that means is that if I know that I'm going to have a comment that takes several lines, I can use this beginning and this end. It's kind of like a bookend for a bunch of books on the top of a bookcase. I can have this block comment, or I can just have individual comments as well. Sometimes people do this, like say for example, let me take off this block comment over here, and I want to comment these lines, right? So I select them, and you'll notice in Visual, now this is a Visual Studio thing, this is not a C++ thing. Over here it says comment out the lines, and when I do that, it'll comment out those lines. And then if I want to uncomment those, then I can click this button over here to uncomment those. It's like a quick C++ thing, Visual Studio thing. All right, let's create some variables. So let's say that I'm going to create a variable age. I'm going to create tax rate. I'm going to create a string called first name, and I'll set that to Robert. I'm going to create a character called initial, and with a single quote, I'll set that to the letter R. I'll create a Boolean variable. We'll say status. I'll set that to true. All right, so this is just a quick reminder of some of the different data types that you can use in C++. An int is a whole number. A double is a real number. That is a number with a decimal point. Now, I could have also done this. I could have said float. Okay. A float is also a real number. It's just a smaller real number. A double, so let me undo, is double the size of a float. Right? So it could contain a larger number. A string is anything with characters. Okay, so Robert, I shouldn't say anything with characters. Really is anything. Like this is a string as well. How about if I put this cuss word? That's a string as well, right? How about this? Yeah, that's a string as well, right? With spaces. So anything with spaces, anything with letters, numbers, symbols, that would be considered a string. So in other words, anything that you can put in between quotation marks is a string. How about a character? A character is an individual item, like a letter, or it could still be a number. I could put the number 1 here. I could put an ampersand or hashtag, dollar symbol. We call those characters. A Boolean is a value that either evaluates to true or to false. And so we call that a bool. And I can manipulate these in any way that I want. Let me also remind you about constants. Now, I'm going to put a constant over here. In general, you don't have to do this, but in general, people like to put constants as global. See, these variables right here, we refer to those as local. It would be as if, like, for example, let me start writing words on the ceiling. Only you guys that are local to this classroom can see the words on the ceiling. But then if I pay for one of those airplanes that does skywriting, right, that's global. Everyone on the Citrus College campus can see that because it's global. It's available to view from a global perspective. But the messages that I write on the ceiling in this classroom are local to you guys only. Only you can see them. So these would be referred to as local to the main function. Over here, if I type something, this would be global. So if I create a constant, I'm going to start off with the word const. And let's say, for example, that I want to create a constant called pi. In general, the convention is that constants are always capitalized. So you can see over here, I have the word pi, and let's say 3.141596. Now I could, of course, increase the accuracy by going to Wikipedia and getting the 100th digit of pi and copying all that and copy and paste. So it just depends on the level of accuracy that you want. So I'll call this global declarations because it is declaring. And this is global. Every single function that I create can see this. Now, is it just limited to constants? No, I can create a variable. For example, let me create an integer, say for example. And the name of that integer is going to be, and by the way, it's not a constant, right? It's a variable. So my number, say for example, and I'll put 14. So as you can see, there's nothing wrong with doing this. It is a global, which means that everything can see this. Now, the reason why some companies or C++ programmers kind of shy away a little bit from global variables is that everyone can see them. That may not necessarily be a bad thing. It depends on the context. In general, programmers like to shy away from globals. I use globals in my programming of the apps that I develop. I just use them sparingly, And so there may be a need for a global variable. You just have to be aware of the consequences. Namely, everyone can see it, and if everyone can see it, everyone can adjust it or maybe make a manipulation when perhaps that's not what you want. Okay. So we call these global declarations. This is an example of a constant. This is an example of a global variable. Okay, good. Any comments or questions? All right. So now let's go over here to the get user input section. And what we'll do is we'll ask the user what their name is. So we'll say, what is your name? And then we'll input that using cin, and we'll put that into the variable first name. All right, so cout, you can think of this as output to the console, even though I don't think that's really what it means, but it's kind of a nice mnemonic. The console is your monitor, and I'm going to be displaying something out to the monitor, right? Now, cin, we basically can think of that as extracting something from your keyboard. So we're obtaining something from the console, say for example. So this is going to get something from the keyboard and put it into the first name variable. Okay, so that's the primary way of using cin and cout. It's to output data to the screen or input data from the keyboard. And so we can ask also, how old are you? And cin, and I'm going to put that into age. Okay. So again, very simple example of the usage of C in and C out. Let's go over some calculations. Okay, so let's say, for example, that maybe I want to take the variable age and I want to manipulate it. For example, maybe I want to double it. So we'll say age is going to be assigned age times 2. And so what this is not is a mathematical function. This is not age equals age times 2. Well, that can't be, because let's say that age is 10. Is 10 equal to 20? Obviously not. But this is a computer science statement that is to be read from the right to the left. So what we're doing is we're saying take the old value of age, update it by multiplying it times 2, then assign it to the new updated age. So if age is 10, 10 times 2 is 20. Age was 10, now it's 20. So it's been updated. So you can think of this as an updating statement.
Equals would be 2 equal signs.
Okay, now that's a very good question. Only when you're using if, say for example, so if if age rather equals 3, say for example. Let me go ahead and put an open and close curly braces. So in this context, that really means equals. Yeah. So you wouldn't want to do that here because that is not assigning. You know what this is? It's asking a question. What if I did something like this for a function? Return age equals 3. Does age equal 3? If that's the case, return true. If that's not the case, return false. So in other words, what two equal symbols together means, is it equal? Whereas one equals symbol just simply means assignment. Yeah. So we'll go back over here and we'll say age times 2, and that just simply means take the value of age, multiply times 2, and that's now updated. All right, so this is an updating statement. How about this? If I say age plus plus, we called this, well, first of all, I'm sorry, let me put the semicolon here. So this increments. This is going to increment by 1. So if age was 10, now it's 11. If age is now 11, it's now 12. So it increments or increases by 1. But specifically what we say about this is post-incrementing. That's different than this, plus plus age. We're still going to increment by 1. But this is called pre-incrementing. So what pre-incrementing does is it says, okay, increment this and now use it. This means use it, and then after it's been used, now you can increment by 1. So let me give you an example of this, okay? So let's say over here, what I'm going to do is I'm going to see out the value of age so that we can see what it looks like. And then after that, let me go ahead and put an end-else statement. So we see out the value of age. So let's say that someone says that they're 10 years old. Okay, so now 10 times 2 is 20. So this is going to see out 20. Okay. Then we're going to do this, and then once again, we're going to see out. So I'll just take this line, and I'll just simply copy and paste it and put it over here. So now that age plus plus, well, it's been incremented, but what will be actually output? That's what we're going to try to investigate. And then over here, after the pre-increment, once again, I'm just simply going to see out what the value of age is. So let's just see what happens with this incomplete program of ours. Let me go ahead and save my work by clicking Save All. And then I'm going to go over here to Local Windows Debugger. Let me go ahead and debug this and run it. And so it's going to ask me to enter my name. So, by the way, just so that I can see this on the video, let me just quickly change the font size to, let's say, 24 points. That should be enough. That's pretty good right there. Okay, so I'll type in Robert, enter. How old are you? So I'll say 10 was my example. All right, so let's take a look at this step by step. So we're going to see out the value of age. Remember, the user entered 10, so 10 times 2 is 20. That's why we see that 20 right there. Okay. Then we did age plus plus. Okay, so that's going to be, I'm sorry, yeah, that's right. Age is this one right here, this is the out statement. Then we're going to say age plus plus, and so what this guy does is it's going to take age, add 1 to it, so we know that's 21. Now we're going to see out age, and so as you can see, 21 gets displayed. And then we're going to take plus plus age, and then we're going to output the value of age, and 22 is sent out. So it doesn't look like anything special happened when I had these individual cout statements. Now let me change that. So now what I'll do over here is I'll say age plus plus. Well, actually, let me display what age is over here. Over in this one, I'll say age plus plus, and I'll say plus plus, and I'll comment out this line and this line right here. So I'm actually going to be post-incrementing and pre-incrementing inside of the cout statement. Well, let's see what happens now with this particular approach. So let me go ahead and run the program. What is your name? 10. Okay, so now notice what happens. Let's take a look at this and investigate it. I used 10. 10 times 2 is 20. So when I see out the value of age, that's where I get that 20. Now, my next line of code, as you can see here, outputs 20. Now, why is that? Okay, so what the post increment really means, the interpretation of this is the following. I want you to see out the value of age, and then after you've see outed it, then go ahead and increment. Yeah.
I have a question. After like you post increment, that value that you don't see, like it's still 20, right?
That's exactly.
Is that value, does that get still into memory?
That's right. It's changed in memory. Yeah, you just can't see it.
Oh, okay.
So I have a box here, right? And I'm putting my hand in the box, and I'm manipulating it. You can't see what I'm doing. But it's still there, actually changed. Maybe I'm incrementing it by 1. Maybe I'm decrementing by 1. Yeah, but you're right. It is changing in memory. Yes?
Does it change how your looping structures work? Like,
Yep.
how you do 4 and then
It sure could.
counter plus
Yep.
versus plus counter?
Yes, sure does. Yeah, absolutely. Because one is post-incrementing. It's using it and then incrementing it. Whereas the other one, the pre-increment, it's incrementing and then using it. So it's like, which order are we doing first? Are we adding and then using, or are we using and then adding?
Could you give me an example of a good situation to use a post increment?
It just depends on when you want the variable to be incremented. Excuse me. If that value needs to be affected before the evaluation of whatever your program is doing, then pre-increment is what you need to do. But if you need to use the value and then modify it, then you would do post-increment. So let's say that we're going to run a race. Okay, so I have a clicker in my hand, and so I better set that thing to 0. Okay, because we're gonna do a mile race 4 times around the track. Okay, so one person says, "Well, my name is pre-increment, so I know I'm going to do a lap, so I'll click right now." The other guy says, "Well, I'm post-increment. I have to run a lap, then I'll click on the clicker." Okay, so in that particular example, it would be better for a person to be a post-increment. You do the lap first, and just as you finished your lap, click, I've ran 1 lap. Whereas the other person says, oh, I know I'm going to run a lap, so I'll click now knowing I'm going to do 1 lap. That doesn't seem like a very smart way of counting. So it depends on how you're counting. Maybe you do want to update the value and then use it, as opposed to using the current value and then updating it. So it really just depends on the situation. What this is showing you is that you have that option. You have an option. Who knows? It could be an esoteric use of pre-incrementing, but at least you have an option to do that. So in this case, you'll notice that age has been incremented. It's just been incremented after it was used. We know that age is 20, so we're still going to display that 20. Oh, by the way, after you display the 20 right here, now I want you to increment it. So in memory, it's now 21. And then over here, okay, take the current value of age. Oh, that's 21. And I want you to increment it, then display it to the output. Okay, so that 21 is now 22, and it displays to the output. Chris, did you have a question? Okay, so it just depends on when you want to increment, before it's used or after it's used. We call that post and pre-incrementing. Now, this brings up a good point what James was talking about. I personally, I try to be very careful and make my programs readable and I try to stay away from this stuff unless it's obvious what I'm doing. Because if somebody sees a pre-increment, post-increment, and if you and I are, okay, what's happening here? Right? It better be worth it. There better be some logical reason why I'm doing something like that.
Is it like a video game? 'Cause for some reason,
It could be.
points.
It could be, sure.
Points at the end of the game.
There you go. You know, so we're going to display those points, but maybe you have to earn them first. So that would be post-incrementing, right? So I grab this star, now it says 1. I grab this star, now it says 2, so forth and so on.
When you get to certain levels of the game.
Maybe, yeah. Maybe there's another application where, yeah, it's giving me like maybe bonuses, right? So it's giving me 3 bonus points. So that was pre-increment, say for example. Again, it just depends on the application, what it is that you're looking for in context. And then, of course, we have post, decrement, and pre-decrement. So I'll just simply do this. I'll say age minus minus. We call this post decrement, and minus minus age, we call this pre-decrement. Now, decrement just simply means to subtract 1 from. Okay, so we are subtracting 1 from age. Both of these are subtracting 1 from age. The question is when, in time, are you doing that? If I put these within the cout statement, this one is going to use the value of age and then decrement it. This one is going to decrement the value of age and then it will be used. So it's a timing thing. Okay. Now, by the way, I think I read in Swift that they're doing away. Now, I know that this is a C++ class, but in some languages they're doing away with this. And they're just simply saying, if you want to increment, just do this. Plus equals 1. So this is incrementing by 1. This is how I would read this. Age is being assigned age plus 1. So let me do some like visual tricks here. Age is being assigned age plus 1. That's how you should think of it. In other words, this is completely identical. So I'll say, for example, this is identical to age equals age, or instead of equals, I should say assigned. And I'll move this over here. Actually, I don't need this. This is exactly the same thing as this. You are incrementing the variable age by 1. This is a shorthand notation. This seems to be the new way that Swift is saying, yeah, this is the way it should be done. And probably it's going to be something that all languages will eventually follow.
That with the operations of times equals 1 or divide equals 1.
Absolutely. In fact, let me go ahead and do that. That's a great comment here. So enter, enter, enter. And sure, so I could say age minus equals 1, which means subtract 1 from age. I could use that also for multiplication, and I could also use that for division as well. Yeah.
Sorry.
Yeah.
Also do that with the whole statements too, like when you add like plus, you could add like multiplication operations instead of plus.
In this case, it's a replacement of. Yeah, so these are replacements of this. Actually, this is not even, I would never do this inside of a cout statement. In C++, if you wanted to post a pre-increment within a cout statement, you could do that. But in terms of assignment, this is a replacement of this outside of a cout statement. You're just simply adding, subtracting, multiplying, or in this case, dividing by 1. This is shorthand notation. Yeah. Yeah.
What if it was age times times? Can you do that?
Oh, yeah, you can't do that. Yeah, I'm sorry, I misunderstood your question. That's just a quick incrementing for decrementing and incrementing.
New system seems better.
What's that?
The new system.
I think so. I think so. Now,
That's complicated.
by the way, I'm old school, so I do this. You know why? Because it's readable. But it's perfectly acceptable to do this. Maybe your boss says, hey, I want everything as optimized as possible. For me, it's always about readability. It's kind of like my friend who's a 8th grade English teacher, and she says, oh my goodness, Robert, look at this. And she hands me a paper of an essay from an 8th grader, and the English is atrocious, and Punctuation is terrible. This is not readable. Okay, so give me something that's readable. Give me a story that's readable, because then I can get the point that you're trying to make. I think the same thing exists in computer science. Try to make your code as readable as possible. Yeah, you may be sacrificing these little nuances here in terms of compressed code, but the better thing is for readability, and most of your bosses would appreciate that. Okay, and let's see here. I think that's it for this particular program, and then I have another part 2 program. So I think what I'll do is I'll just use this program. I'm going to give you the code. I have it on Blackboard of what I'm covering, but I'm just going to put them together. And in the output section, I could output any of these items, like something like this. Your age is, and then put whatever that variable age is. And I'm going to go ahead and put the endl. If I didn't mention it already, endl just simply means go to the beginning of the next line. Now, the old C way of doing this would be as follows. And so let me comment this out. And if I were to consider something like this, C out, you are, what did I put over here? Your age, oh, I'm sorry, I meant to be your age is, space, and then whatever the age is. I could do this, \n. So \n, we call that an escape sequence. There's all kinds of escape sequences. \n just simply means go to the beginning of the next line. \t means hitting the tab. It's like hitting the tab button. \b, as in boy, means pressing the backspace button. So if you wanted to, you could do an internet search. Let's see here. Let me go over here. Let me type in C++ escape sequences. And I'm sure I'm going to get a list of all of the different escape sequences. Here we go. Let me zoom in a little bit. So if I wanted to display a quote, like for example, Hamlet said, quote, to be or not to be, close quote. Well, then I'd need a \quote to actually display the quotation mark. What if I wanted to display a backslash? Well, then you need the \\/ to display the backslash. If you want to go to the beginning of the next line, so we call that a line feed new line. See, when you press enter, really two things are happening. You're going to the next line, and then you're going to the beginning of that new next line, right? So two things are happening there. We call that \n. Whoops, sorry. Let me go back over here. Tab, vertical tab, an audible bell, right? If you want to hear a ding. So these are all the escape sequences that you can use in C++, and I just simply did a Google search for that, as you can see. Okay, let me go back over here. All right, so both of these achieve the same goal. Comments or questions? Okay, let me go back to the top over here. And what I'm going to do in this section over here is I'm going to type in a function prototype. So let me put a comment over here, function prototypes. What a function prototype is, it's kind of like a precursor or a pre-statement of what you are going to be doing when it comes to functions. I guess the only analogy that I have here is an old one. You guys don't remember this, I'm sure, but when I used to go to school, we had card catalogs. And a card catalog was this drawer that you would open with a bunch of index cards. And you needed to find this particular book on calculus, specifically differential calculus, and then you had this author, and it gave you a little bit of a preview, talks about high-level differential equations for engineers. I don't want that. Talks about high-level differential equations for mathematicians. Okay, that's the one that I want, for chemical engineers, for petroleum engineers, blah, blah, blah. So where is that book located? And it told me a little bit about the book. We call that an abstract. Told me about the book location, the author, so forth and so on. That's kind of like what a function prototype is. It's just a little tiny bit of information of what you will find out, the full information when you get the book later on. We call those function definitions. So over here for the function prototype, let me just do this. So I'll say double sorry, double my square, it, and then I'll put the variable over here, int, and let's see, num parameter, and a semicolon. So let me remind you about these function prototypes. What is the name of the function? My square it. What parameter does it receive? Well, in this case, it receives an integer, and that integer, I'm going to call it num parameter. When this thing is finished, does it give anything back to you? It sure does. It's going to give you a double. Okay, so this is the return information. What is it going to return back to you? Okay, so imagine that I have a frisbee, and so on that frisbee, I have a number that's written on it, the number 10, and I throw it to you. You have a Sharpie, and you take that and you square that number 10, so you write 100, and then you throw it back to me, and so I get 100. Okay, so I give you something in order for me to get something back. So these are functions that return values. Now, if a function has void here, then that means that this thing doesn't return anything, right? It would be like, for example, I'm playing frisbee, and this happened to me one time. I was playing frisbee in the park, and some stray dog over here, when I threw the frisbee, grabbed the frisbee and took off. Bye frisbee, right? That would be a function that doesn't return anything. You send it a parameter, it took that parameter, but it didn't return anything back to you. We call these void functions. Now, it may very well be that I have a function like this that does not receive any parameters. A function doesn't have to receive parameters. It's up to you what you're doing, what you want to create. Maybe I'm going to create a function that you just simply call it and it says, thank you very much, have a nice day. So I call it my, what's that called, salutation, I guess, or maybe benediction. You know, like I just want to say, hey, thank you very much, have a good day. So I call a function that does that. I don't expect anything to be returned, and I don't have to give you anything because your job is to send out some sort of a benediction, right? So functions don't have to receive parameters, or they could. Functions don't have to return something, or they could. Again, it's just up to you. What do you need? So this makes you, as programmers, very powerful because you're kind of creating your own tools. I wish I had a tool that did this. I want to give it a number, I want it to square that number, and then I want it to return the results back to me. And I gave you a whole number, but I want you to return it to me as a double. Or maybe I gave you a whole number and I want you to return it as a whole number. And it's up to you. Maybe I gave you a whole number, but I want you to return the word. Sorry. I want you to return the word. So in other words, let's say that I give you the number 1, but I want you to send back ONE. I gave you the number 2, but I want you to send back to me TWO. Well, that'd be a pretty cool program, right? Taking numbers and converting them to words. So again, it's whatever you want. So in this case, I'll just stick to what I had before. I think I had double there. That's fine. All right. So this is referred to as a function prototype. What I'm going to do now is I'm going to copy everything with exception to that semicolon. That semicolon tells the C++ language this is a function prototype. I'm going to take this with exception to the semicolon and copy. So Control C. Then I'll go all the way down here to the bottom and press enter a couple times, paste, and then put an open and close curly braces. So this is referred to as my function definition. So the function definition, now that's the fleshing out of what the function is supposed to actually do. All of the code of what my square it does appears here. This is kind of like a precursor. Hey C++ program, just know that later on you are going to get a full definition of what my square it does. The only thing you need to know right now is that it's going to need an integer to do its job and it will return a double. That's what this thing does. Over here, now I have to truly flesh out what my square it is going to do. And because it has a double over here, I have to say return whatever the value is. Okay, so now let me do it kind of like let me do this in an overly rhetorical way, maybe like taking too many steps way, and then I'll do it in a more efficient way. I'll comment out the code. So let's say that we're going to do this. I'm going to create a variable called temp, and temp is going to be assigned the value that I sent. Now, you wouldn't want to do this. I'm just explaining and giving you some ideas of what you could do. Okay, so temp is now whatever was sent to me. Let's say it's the number 10. So temp is now 10. And let's go ahead and create another variable. This will be a double. And we're going to call this result. And so what result is going to be is result is going to be temp times temp, right? Because that's what square it really does. It's just the multiplication of itself. And then when I'm finished, I will return whatever the result is. Okay, so let's go through this. I sent you a number, like me throwing you a frisbee, and there's a number written on there. So I take this number, and I'm going to put that into that number that I sent to you. I'm going to put that into a variable that I call temp. I'm going to take temp, I'm going to multiply it times itself, and I'm going to put that into a variable called result. And then I'm going to return a double, specifically result, because that's what result is. It's a double. I'm going to return to you the double. So let me type a couple of comments here so that you can understand what's going on. Let's say that numpar, let's say that it's equal to, I'll put two equal symbols here, 10. So over here, temp is now equal to 10 because numpar is being set or assigned to temp. So temp is now 10. Now, temp times temp is really the same thing as 10 times 10. But result equals 100.0. This is an integer. This is an integer. An integer times an integer is an integer. But I am assigning this to a double. So yes, temp times temp is 100, but because I'm putting it into result, which is a double, I add the 0.0 because this a double is a real number, a number with a decimal point. And so therefore, what I'm going to be returning in this particular example is 100.0. That's what I'm returning. Comments or questions? So far, so good? Okay, yes?
Do we have to assign temp to be numpar? Can we use numpar?
Very good. No, kind of a waste of time for me to do that. I don't have to do that. So why don't I do this? Let me show you like a more efficient way of doing this. So what I'm going to do is I'm going to take all this. Let me see. Can I comment that out right here? Yeah. So let me just comment that out. And what I'll do is I'll push that down. Type in what probably we should do. Return numpar times numpar. Okay, that's pretty easy. We're just simply squaring it, and we're going to return it. Now, because I'm going to return a double, it will take this integer times this integer. It'll cast it as a double. So, see, in C++, casting can only occur when you're promoting something. Casting does not occur when you're demoting. There's no automatic demotion. So let me explain what that means. 10 can be promoted to 10.0. So an integer can be promoted to a double and no loss of value, right? 100.0, no loss of value. How about this? Can I take 3.14 and demote that to an integer? Well, 3.14 becomes 3. Okay, I've lost value, specifically the 1.4. C++ will never automatically demote. You have to forcibly cast it if that's what you want. Kind of like my son one time went to the bank and he insisted, I don't know, he had a fetish for $50 bills. And so he gives the banker $156.23 and goes, I want as many $50 bills as you can give me. You know the answer. The teller gives back 3 $50 bills. Now, of course, the amount returned was 3 point something, but you're only interested in that 3, right? So you you've taken a real number and converted it into an integer, right? And that's what you can do forcibly. But C++ will never do that. C++ will never demote. C++ can promote. So a 10 can become a 10.0, but a 10.0 can never become a 10, at least C++. Maybe I force it to be that way. So what I'm talking about in C++ is this. I can take, let's say for example that I have double temp. Okay, so I can take and then int temp2. I can take temp2 and assign it as an integer. Oops, sorry. Whatever temp is. So what this does is it says take temp, which is a double, temporarily treat this as a whole number, and then assign it to another whole number. So I have to forcibly do this. Okay? What I do not have to do is put a cast for temp2, because what will happen is the C++ compiler will say, oh, this is an integer, but you want me to put this into a double, so I'll take that integer at a point 0 and then put it over here. So we call this promotion. C++ can promote, but it cannot demote. You have to forcibly do that because C++ doesn't know. You could be losing value. 3.14 becomes 3. You just lost value, so we don't want to do that.
So temp, when you temporarily treat it as an int and assign it to temp2, temp still is an integer, but temp2 is.
That's exactly right.
And
Yeah.
it doesn't change until you change it later if you want it.
Yeah, yeah.
Static cast.
You could use static cast as well. Yes, yeah. This is kind of like the old C way of dynamically treating this as a different type, just temporarily.
What's the difference between static cast and that kind of cast?
Static cast does additional things, additional items like, say for example, if you take an integer and you static cast it as a character. So if I took the number 97, it would return the letter A. 98 would be the letter B. This doesn't do this.
Oh, so that's basically just for numbers.
Yeah, exactly. Casting them as
It's like
doubles.
keeping like the on switch on, the on stays on, static, because it's static, right? It's always the rest of the program.
Yeah, it maintains it that way throughout the. That's what static means. But static cast means something different. It can do this, plus it can do like character to integer, integer to character conversions for you. Yes, question.
Yeah, I was going to say ask. Could you go from integer to character?
And then character to integer. Yeah, with the static cast. Yeah, with this type of casting, it's just promoting numbers or demoting numbers, maybe.
So static cast basically reveals, like, say, like letter W or R would be number 119. With static class, will just show you, instead of like putting W, you just do like roll with that.
Yeah, exactly. So if I go to the ASCII character table website, it looks like the lowercase letter A is really 97. So if I put static cast character, and if I gave it the 97, it would return the letter A. If I put static cast integer, and if I give it the letter A, it would return 97. So that's what static cast can do. But go back over here. This is just meant to cast something from an integer to a double, or double to a float, or whatever you want in terms of how do you want to temporarily represent this number. So promotion always occurs. Demotion does not occur. You forcibly have to do that. Okay. All right. I don't like this. Right? Why don't I try something else? So let me go ahead and take all this. Well, it's not that I don't like it. I just want to show you something else that we can do. Return, and let's see here. So if we do pow. So pow is a function that says take the number as the base, and we'll say num parameter. And what do you want to do with it? Well, in this case, I want to square it. And you see that this right here indicates all of the different flavors of pow. So it looks like I can give you a double. That's the base. This is the exponent. I can also give you a double and an integer, and so forth and so on. These are all the different flavors. So this is just meant to be information. I don't select this. It just kind of like an index of all the different things that you can do. Let me make sure I put the semicolon over here. So what this is going to do is it's going to call a function called pow. It's going to take that base, it's going to square it, and then return the value as a double. By the way, that's what pow does. As you can see over here, pow, I'm going to move my mouse and it's going to take it away, but put your eyes right here. Put your eyes right here. See that we're double? So what does pow do? It returns a double. Okay. Now, if I wanted to cast this as an integer, sure, I could do that. Just parens, int, close parens. And it would temporarily cast it as an integer. Maybe you're only working with values. Like, well, actually, when you square something, if you square two integers, it's always going to be an integer, right? So maybe you want to deal with integers only. Again, it's up to you. Okay. Comments or questions? Does this make sense?
Powers, like if you wanted it to be like a number squared and then like cube rooted.
Yeah.
Like 2.3.
Yeah.
Or I think that's
Yeah. If you want to cube a number.
well, like if you want to like cube the number and then take the square root of it.
Sure. So if I wanted to do that, I would do something like this. SQRT is for square root. So what I'm going to do is I'm going to square root the results of this. So first it would find out what this number squared is, and then it would square root it. And let me get rid of that space. So I can embed functions instead of functions.
It's like your power is like your math toolbox.
Your pow is like this. Let me write it on the board. Your pow is basically x to the y power.
Oh.
That's what pow does. In this case, in this context, we took 10 to the second power. So that's where this number is. That was the 10 that was sent. And this 2.0 is this guy right here.
And because of the square root of this and you square root of this.
Yeah, so then we're taking this and we're going to square root it. So 10 to the second power is 100. 100 square root is equal to 10.
That's a good way to do absolute value. So if you create a negative 10 and it squares it, makes it positive.
Sure, absolutely, yeah, because squaring any number is basically going to absolute it. Now, there is a function that does that. Yeah, so let me just press enter over here, ABS. So ABS is absolute value. So if I wanted to find out what the absolute value is of negative 10, it would display, let's say, for example, if I do cout, right, cout this, then it would display positive 10. And then, of course, if you just said cout ABS positive 10, well, nothing changes because the absolute value of a positive number is still positive. The absolute value of a negative number, it just changes it into a positive. So, or you could use your mathematical approach. Hey, since we're talking about fancy schmancy mathematical approaches here, what if you did something like this? Okay, so what does this mean? If I say, what is 8 to the 1/3 power? Does anybody know what this is? Nice. This is really the same thing as what is the cube root of 8. But here I can use power, right? Because there is no function called cube. There is no function called, I don't know, what the 4th root or the 5th root or whatever. So if I had something like this, I would just use pow 8, comma, and then I just say 1 divided by 3. Could I put 0.333? Yeah, I could, but I think this is better because let the compiler do that and carry out the number of significant digits as much as possible. So let me put this on the screen so it's recorded. I'm going to temporarily comment this out just so I can say, okay, return the pow, and if I had some number like 8 to the 1/3 power, that's really the same thing as the cube root of 8. So I could just simply put 1.0 divided by 3.0. And so this is the cube root of 8. That's what would be returned. Oh, sorry, my mistake.
Do you use the modulus operator?
You can use, you're asking how to use it?
No, do you use it like the percentage?
Yeah, the percent symbol in C++ is the modulus operator, yeah. Yeah, well, let's talk about that in a bit, actually. So, you know, Samantha's coming up with some nice little mathematical tricks for absolute value. This is a good trick for cube rooting something, or quad rooting something, or 5th rooting something, you know, whatever the actual fraction is. You can just simply use power for that. Okay. James, you mentioned something about finding the modules. Well, you know that
Would you use the modulus instead of the backslash for that? Because I was trying to understand because it returns. It's supposed to.
this slash right here can only mean division in this context. Now, if I wanted to use modulus, then I could say something like return 5 mod 2. Okay, so this is really the same thing as what is the remainder of 5 divided by 2, which, for example, means 5 divided by 2. So what is the remainder of 5 divided by 2? Well, 5 divided by 2, 2 goes into 5 2 times with a remainder of 1, so this thing would return 1. And we use, like you mentioned, the percent symbol for modulus. This over here can only mean division. Yeah. All right, so let me restore order to the universe. And this thing is supposed to square a number, so that's what we want. Right? But that's okay. We're going off topic and covering all kinds of stuff about C++, just to bring back to memory all those, all those features about functions and arithmetic operators and stuff like that.
Do you have to import the math library, or is that just for Java?
Yeah, this is great. Yeah, in Java, you have to incorporate that, but with standard, you're set. Now, check this out. I'm going to comment out this line, and let's see what happens. So let me take this guy and comment it out. And if I go down over here, then I'm going to see all kinds of different errors. So let me go ahead and build it. And so as you can see, we've failed in a number of different areas. So it looks like it doesn't know what cout means. It doesn't know what cn means. It doesn't know what end-to-L means. It doesn't know any of these, what these lines mean. Now what I could do is I could do this. I could say standard : Now look at all these tools I have. Absolute value, arc cosine. So those are all trigonometric features. Let's see if cout is there. Yep, I'm sorry. Cout. There it is. Cout is something. How about POW is a tool that's in the standard library. SQRT, that's a function over there. Absolute value, ABS. Okay, so in other words, the standard library has a bunch of tools, so I don't have to bring in cmath.h. It's all part of the standard library. Now, some programmers like doing this. Some programmers like saying std : cout hello, and then they'll put a \n over here to go to the beginning of the next line. Some programmers, come from that old school perspective. If you're going to do that, you'd have to include the std and everything. I don't. So what I would do is this. Using namespace, std is the way to bring in the standard library and include all those tools.
So std is the library, but then the different like math and whatnot, how those
are tools inside of this library.
But are they classes or?
Those are tools. Those are objects. Yeah, they're not classes. So a class is the abstract, and the object is the actual tool that you can use. So cosine, sine, tangent, pow, square root, those are all tools inside of this particular library.
But there are classes in that library that create the objects.
I don't think that you would refer to those as classes. You would refer to those as objects. So the arc, cosine, sine, tangent, all those mathematical functions, they are objects inside of this library. So you would think of this library as the class, actually. And those tools would be the objects. Good. Other comments or questions? Okay. So, wow, we're having so much fun. I forgot about how it's the computer science meeting today. And so I got to wrap things up. But I'm having so much fun here. So let's see here. What else can I do really quickly to remind you about C++ here? Oh, you know what? We have to talk about passing by reference, just to make sure you understand that. So let me go back over here to the top of the program. And let's say that I'm going to create a void function. Let me see, what did I do? I called this thing myExponent function. And I'm going to send you a base parameter. I'm also going to send you exponent. parameter. And I'm going to pass by reference. See that ampersand right here? That ampersand right there, we call that the address of operator. What this means in this context is pass by reference. Pass by reference, to bring to your recollection, simply means you are sending the original. So, in baseball, for my little kids, I got this one kid. He's 7 years old, but I swear to God, he's almost as tall as me, right? His mother's huge. Father's little, so that's weird, right? And maybe the height gene is passed maternally. Anyway, this kid's big, right? And of course, every game that we go to, yeah, I want to do a birth certificate check on that kid. Yeah, what are you doing? You're throwing in some ringers in there just so you can win. No, this kid really is 7 years old. He just happens to be huge, right? Almost double the size of my son. Will that parent give me the original birth certificate or a copy of the birth certificate? A copy, because that original is valuable. Something happens to that original, oh gosh, you got to go to the court and reestablish. And why do you need another one of these? Because we don't like to just print out, originals all over again. So you're going to make a copy. That's typically what you are doing when you are passing parameters in a function. You are passing them by value. You're making a copy, and you gave me the copy. You keep the original. But there are times when you do want to give the original value to a function, and so that's what we call pass by reference. Technically, what you are doing is you are sending the address of that particular item. So it can go right to the spot and say, oh, you have 3 in this address location. You have the word Robert in this address location, or whatever it is that you have. You are sending the original value. The only way to do that is to use this address of operator or the ampersand. So what we'll do is over here we'll say result of x to the power y parameter. So I'm going to give you a base, I'm going to give you an exponent, and you are not returning anything. See that word void right there? You're not returning anything. But something will happen. I will end up getting the value, and that's when I'm going to go ahead and create a variable over here called int result of x to the y power. What is the result of x to the y? We are going to put something into here, even though this function doesn't return anything. So let's see how that works out. So let me go ahead and take this function prototype with exception to the semicolon. We go all the way down to the bottom. Paste it, and then open and close curly braces. And what I'm going to do over here is I'm just simply going to say, okay, you gave me this original. Okay, here's another analogy. So, in the Olympics, I love watching the 440. Who doesn't like watching the 440? I mean, that's an exciting race. That's where you have to run one time around the track, and you got that baton, and you're just wondering, are they going to drop it? Because it always happens, right? One team drops that baton, and and when the Americans did it that one time, and I thought, oh my gosh, we were supposed to win this. The Americans dropped it. Oh, what were you thinking? It's just such an amazing race. You take that baton, and you run, and you hand off the original baton to someone else. That's exactly what's happening here. We are handing off the baton. There's only one baton. It's the original value that's being passed. Here it is. I've just received the baton. Here, let me go back over here. Here's the baton. I am going to give you the original baton. Ready? Ready? Here you go. Here it is. I just gave it to you. Now, by the way, what I am going to be giving to you is this. This guy right here. I'm going to give you that baton. You change it in some way. Maybe you write something on it, say, for example. And so now I'm going to be able to see your changes as you make them. So back over here, let's finish this function, and then we'll wrap things up. So I can't return anything, as you can see over here. What I'm going to do is I'm just going to simply say the thing that you just gave to me, this result of x to the y power, this is simply going to be me using the power function, and I'm going to take the base that you gave me, I'm going to take the exponent that you gave me, and I'm going to raise this to this power, and I'm going to assign it to result of power x to the y power parameter. When I go home, my wife hopefully, if we're not arguing. She says, "Hi, honey." My son says, "Hi, Daddy." Are they both referring to the same person? Yeah, they're both pointing to me, except that one person calls me one thing, another person calls me another thing, but they're both referring to the same thing. That's exactly what's happening here. In this function, I am referring to the value that was passed to me by reference as result of x to the y power parameter. But really, it's the same thing as this guy right here, result of the x to the y power. So let me show you how that works. Okay, so I'm looking at my notes here because I want to make sure that I'm consistent. Okay, so we can do something like this in the calculations section here. I'll just do something like this. I'll say cout, enter a base number. And we're going to put that into, let me see, did I create a variable called? I didn't, sorry about that. I have to create the variable, so we'll say my base, and I'll create my exponent. And then I already have this. So this to this power is going to be placed into here. Okay, so go back over here. And so I'll cin, and I'll put this into my base, cout, enter an exponent number. Put that into my exponent. Now that I have that, I can call this function called my exponent function. That's that thing that I created at the bottom. What am I going to give to you? I'm going to give to you, well, it says here that I got to give to you the base. I have to give you the exponent. And you are passing by reference this variable called result of x to the y power parameter. Okay, so let me give you the base, comma. Let me give you the exponent, comma. Let me also give you this result of x to the y power. So in other words, I'm giving you this. I'm giving you this. But notice how I'm going to give it to you. I'm going to pass it by reference. And so as you can see over here, I'm passing it by reference. I'm giving you the original. Here, I'm giving you a copy. Oops, sorry. Here, this is a copy. Here, this is a copy. This is the original. You change the original over there, you're still changing the original. When I get the original back, you've changed it. You modified it. Okay, so now what I can do is I can put this within a cout statement, or do something like this. Cout my base raised by whatever the exponent is, my exponent, equals, and then result of x to the y power. Go to the beginning of the next line. Okay, so let's see what happens. So what is your name? Robert. How old are you? I'm 10 years old. Okay, so enter a base, so we'll enter 2. Enter an exponent, we'll enter 3. Press enter, 2 raised by 3 is equal to 8. Okay. So in other words, what I've just done is I've output this value, and this function never returned anything. So we did that by passing by reference. Okay? All right. So this is Professor Robert Solis. Have a good day. See you next time.